We've all heard about parallel universes in sci-fi, but did you know some scientists actually believe they might exist? And if you thought these were just figments of science fiction writers' imaginations, think again. The idea is rooted in the strange world of quantum mechanics. In our everyday lives, things are either on or off, black or white, up or down. But on the subatomic level, the rules are completely different. There, things can be in two states at once. For example, a particle could be spinning clockwise and counterclockwise simultaneously. That's called superposition, and it's one of the foundations of quantum mechanics. But how does that lead to parallel universes? To answer that, we have to take a closer look at what exactly a universe is. Scientists generally define it as everything that exists, including space, time, and matter. But what if there's more than one universe? What if there's an infinite number of them? That's the idea behind the many worlds interpretation of quantum mechanics. It was proposed by physicist Hugh Everett in 1957. And, as the name suggests, it says that our universe isn't the only one out there. In fact, there are infinitely many parallel universes. According to this theory, every time a quantum event occurs, such as a particle decaying or being observed, it creates a new universe. And in each new universe, the particle ends up in a different state. For example, imagine a quantum particle that has a 50% chance of landing on heads or tails. According to many worlds, every time it's flipped, two new universes are created. In one, the particle lands on heads, and in the other, it lands on tails. Now, imagine flipping the particle again. If each possible outcome spawns a new universe, we end up with 4 of them after 2 flips. In the first, the particle lands on heads twice. In the second, it lands on heads and tails. In the third, it lands on tails and heads. And in the fourth, it lands on tails twice. And the same thing happens every time any quantum particle decays or interacts. Over billions of years, this creates a vast, ever-growing multiverse. The idea may seem far-fetched, but it's actually rooted in the mathematics of quantum mechanics. When physicists describe how quantum particles behave, they use something called a wave function. It's a mathematical equation that contains all the information about the particle's properties. When you observe a particle, its wave function collapses. But before that collapse, the wave function evolves according to the equations of quantum mechanics. And those equations are deterministic, meaning that given the right boundary conditions, they always produce the same result. Now, in our everyday lives, we never see evidence of this deterministic behavior because quantum particles are so small that their wave functions are extremely fragile. They collapse almost immediately when they interact with anything. But in a perfect world, without any noise or interaction, a particle's wave function could evolve forever, branching out into an infinite number of new universes, each representing a different possible outcome. That's the basic idea behind the many worlds interpretation. Every time a quantum event occurs, it causes the universe to split. Unfortunately, the idea doesn't come without problems. It raises what's known as the measurement problem in quantum physics. To explain, let's go back to our spinning particle. It's both spinning clockwise and counterclockwise until we measure it, but then it seems to suddenly drop into one state or the other. How does that happen? In the many worlds interpretation, it doesn't. Instead, when we measure the particle, its wave function continues to evolve. We just happen to find ourselves in the universe where it landed in a particular state. But wait, why do we only find ourselves in one universe? Why don't we experience all of them? To understand that, we need to talk about decoherence. It's the process by which quantum links between systems get lost, causing them to act like they're in separate universes. For example, imagine a cup of hot coffee sitting on a table. Its molecules are constantly moving around, but if we start looking at them, they seem to freeze in place. That's because the quantum links between the molecules and the rest of the room get lost. The molecules effectively decouple from the environment. In the same way, the more a quantum system interacts with its environment, the more its wave function fragments and the harder it is to detect the interference between the fragments. Eventually, the system becomes so entangled with its surroundings that it no longer behaves like a quantum system. And that's where the many worlds interpretation says we find ourselves in one particular outcome. So the apparent collapse of the wave function isn't really a thing. Instead, it's an interpretation problem. The reason we don't see all the possible outcomes is because we find ourselves in one particular universe. Many worlds is one interpretation of quantum mechanics, but it's far from the only one. Most physicists agree that the math works, but they disagree about what it means. Some say it's just a way of looking at quantum mechanics and it doesn't have any physical implications. Others think it represents reality, but they can't agree whether we actually live in a multiverse or just one universe. Physicists like Richard Feynman believed that the idea was unnecessary and confusing, and he developed his own interpretation of quantum mechanics that didn't require parallel universes. But the idea still has its supporters, like Nobel laureate Elias Frisch. He said that many worlds is a good approximation for describing the behavior of open quantum systems like those found in everyday life. What do you think? Do you think parallel universes exist? Let me know in the comments. And I'll see you next time. If you want to learn more about parallel universes, check out this playlist. And thanks to all my patrons for supporting this channel. If you want to support the channel too, you can find the links in the description. And thanks to everyone for watching. See you next time. There are two kinds of science fiction. There's the kind that extrapolates current technology and asks where it might lead us, spaceships and robots and all that. And there's the kind that starts with a scientific idea and asks what might be possible if we took that idea to its extreme. Many worlds and parallel universes and stuff like that. Today, we're going with the second kind. More specifically, we're going to talk about quantum mechanics. Now, you don't have to know anything about quantum mechanics to enjoy this video, but knowing a little bit will help. So here's a primer. At the heart of quantum mechanics is the idea that particles can be in two places at once. We call this superposition. Once a particle is in a superposition, it has the ability to be in multiple states at the same time. Like maybe it's spinning around really fast and it's also headed straight for you. Now, the question is, when does this end? When do those possibilities collapse into just one reality? Well, according to some interpretations of quantum mechanics, when you measure a particle, you force it to be in only one state or another. But what if it doesn't collapse? What if both possibilities become real? That's the idea behind many worlds. The many worlds interpretation was proposed by physicist Hugh Everett in 1957. It says that every time a quantum event happens, like a particle being measured, it spawns a new universe. In the new universes, all possible outcomes of the measurement are realized. So in some universes, the particle is in this state, and in other universes, the particle is in that state. This creates a vast multiverse, a many branching universes where everything that could possibly happen does happen. It's a weird idea, but it's a useful idea. It neatly sidesteps the measurement problem in quantum mechanics. But does it actually describe what happens at the quantum level? Well, we don't know. We can't test it. Some physicists say it's just a reinterpretation of quantum mechanics, while others say it's just plain wrong. But let's assume for a moment that parallel universes do exist. What would they be like? Well, in each parallel universe, things would be different. The laws of physics might be slightly different, or the constants of nature might have different values. Maybe gravity is weaker, or particles have different masses. In some parallel universes, the chemical composition of the planet might be different. Maybe life evolves differently or never evolves at all. Maybe the Big Bang never happened. In some parallel universes, you might not exist. If parallel universes do exist, we probably can't interact with them because they'd have to have different physical laws. Also, they'd probably be in different dimensions. So the next time you're watching TV and you see a commercial for Life cereal or something, remember, in some parallel universes you might not exist, and therefore there would be no one to sell Life cereal to. I'm the host, this is my channel, and I want to give a big shout out to my patrons who make videos like this one possible. If you'd like to support this channel, you can do so today at our support page.